Alright, welcome to the very first part of this Algebra 1 DVD, which is going to be opposites, integers, and absolute values, alright? So let's just begin, let's just dive right in. So, the very first thing we're going to start off with is we're going to start off with definitions. Just get those guys out of the way so we can just start with what's actually important, which is doing the math. Okay, so that's what I'm going to try to do in these videos. Is basically I'm just going to try to give you guys the definitions because they are there, they are important, but I personally don't think they're as important as actually doing the math. So let's start off with that. Okay, so a real number. A real number is basically just a number that can be written as a fraction or a decimal. Okay, put that in your notes. A natural number. Okay, a natural number is basically just, it starts off at 1, and then 2, 3, 4, 5, 6, 7, 8, 9, 10, forever. So it starts off at 1, and it counts on. So again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, I could be here forever counting numbers, but those are natural numbers. Whole numbers. Whole numbers are the same exact thing as a natural number, but it also includes 0. So instead of going 1, 2, 3, 4, 5, 6, 7, 8, 9, it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for eternity, okay? So that's a whole number. Now, integers. Integers are important. We use integers always, especially when we talk about money. An integer is basically a negative number all the way out to negative infinity, coming all the way in to positive infinity. So, in other words, these little dots, by the way, that just means it goes on forever. So, like, it only starts at negative 5 here, but I mean, it goes on negative 6, negative 7, negative 8, etc. So, basically, it goes negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, forever. Okay, so hopefully that makes sense. That is integers. Again, real quick, if you have to, you could hit the pause button, put these guys in your notes because you should be taking notes. If you're not taking notes, pause this right now, go get a notebook and a piece of, something to write with, a pencil, and come back to this guy because you should be taking notes. All right, so let's just jump right into some of the fun stuff, right? Alright. So, the very first thing we're going to talk about here is something called inequalities, okay? So, what an inequality looks like is it basically looks like this. It just looks like an alligator mouth, okay? So I'll draw it again a little bit lower. So it just looks like that. So this is what's called a less than symbol. So this is less than, and this is a greater than symbol, okay? And the way they teach it, to kids, I guess, is, which I think it helps, is they draw little teeth in this guy. So it kind of looks like an alligator, right? So it kind of looks like an alligator. Well, basically the alligator eats the bigger number, okay? So it's going to eat the bigger number. And you'll see an example of what I mean. So I'll leave these guys up here. So basically the first example, let's say we have the number 3 and we have the number 1. Well, you have to basically fill in the blank and say, okay, is 3 greater than 1? Or is 3 less than 1? Okay? So, in this case, remember, the alligator always eats the bigger number. That being said, it's going to eat the 3. Does that make sense? Okay, so hopefully that makes sense. So, 3 is greater than 1. Let's try one more of those guys. So we got 6 blank 8. So another way I like to think about these guys is money, because everyone uses money. So you think, okay, if someone has $6, someone has $8, who has more dollars? Who has more money? Well, the guy who has $8, right? He can buy more things with that. So the alligator, again, eats the bigger number, okay? So that's an introduction to inequalities. Now what we're going to talk about is we're going to talk about opposites, okay? Opposites aren't too bad. So, for example, let's say we have the number 6. The number 6. Well, what's the opposite of 6? The opposite of 6 is going to be negative 6. Okay? So the opposite of 6 is going to be negative 6. The opposite of negative 6 would be 6. Okay? So let's do one more of those guys. I think you'll get the idea. So let's say we got negative 2. What's the opposite of negative 2? Well, I'll give you a chance to try to figure that out. What's the opposite of negative 2? I'm sure you got it. It's going to be positive 2. Okay? So hopefully you get the idea on that guy. Alright. Now let's visit inequalities again, but this time we're going to use integers. Okay? So I guess we're going to use more integers rather. But what I mean by that is now let's throw in some negative numbers in here. Now these guys can be a little tricky, okay? So again, you're going to try to fill in this blank with a less than symbol or a greater than symbol. Now how I try to think of it, okay? Again, money. Let's say you have a bank account, you know, and if you don't have a bank account, think of negative means you owe someone money. So you might owe your parents money, or you may owe the bank money. I hope not. I hope that's not the case, but in this example, unfortunately we do. So this person owes someone $3, and this person owes someone $7. So whoever owes the least amount of money is going to have more, okay? So in this case, the negative 3 is greater than negative 7 because this person owes less money, okay? So hopefully that makes sense. If not, rewind this, you know, just a minute or two and rewatch this because negative numbers, unfortunately, don't go anywhere. They're going to be here for a while. So the next example, we got negative 2 blank positive 4. So I'm going to give you a second to try to figure out which one of these guys do you think is less than and greater. Like which way are you going to put the symbol. And again, hopefully you're writing these, you know, these examples down, following along, and you know, doing it yourself. Try to answer them before I give you the answer, and you'll really know if you're understanding it or not. So we got a negative 2, and we got 4. Again, who owes less money or who has more money? So this person owes someone $2. This person has $4. Okay, so the guy with $4 is going to have more money. So again, the alligator eats the bigger number. Okay. So the last topic we're going to discuss in this video is absolute values. Okay. So the definition of an absolute value, again, put this in your notes. It's the distance from 0. So that's the actual definition. So actually doing the problem, you're going to see it's not too bad. But again, it's the distance from 0. So distance is key word, and I'll tell you why. So absolute value bars, it just looks like 2 bars on the left and the right side of the number, okay? So this is what's called absolute value. So it's read like the absolute value of negative 2. So That being said, remember, we're talking about a distance. A distance can never, ever be negative. I mean, who's ever going to say like, oh, I just ran -2 miles? Or it doesn't even make any sense, right? Or the door is -9 feet tall. It doesn't make any sense. So what I'm trying to say is the absolute value of -2 is just +2. The absolute value of anything will always, always be positive, okay? So, I'm going to try to trick you guys right now. What's the absolute value of a +4? So I'll give you guys a second. Alright, well, again, the absolute value of 4 is just 4, because the absolute value is a distance, and a distance is always positive. So if the absolute value is of a negative number, you just make it positive. If the absolute value is of a positive number, it's just going to be positive. Okay? Now, I just threw one more guy in here in case you have homework or something and they try to trick you with this guy. The absolute value of 0. Well, the absolute value of 0 is just 0. Now, there's no such thing as -0 or +0. 0 is it's pretty neutral, it's just 0. So keep that in your notes in case that ever arises, but the absolute value of 0 is 0.